Now let's talk about calculating the pH of a solution that contains a strong acid. In this problem, we're asked to determine the concentration of H plus in a 0.8 molar HCl solution. In order to devise a strategy for solving this problem and to determine what type of problem that we're working with here, it's helpful to take a look at the list of acids and bases and find where HCl appears. Pull up the table of acids and bases, and what we see is that HCl appears up here at the top, and we also see that it's indicated that the Ka value of hydrochloric acid is very large, meaning that hydrochloric acid is a strong acid. There's a certain strategy that we're going to use for solving a problem that involves a strong acid. So since HCl is a strong acid, meaning that its Ka value is much greater than 1, that means that the reaction for the dissociation of HCl very heavily favors products. And what we're going to say is that it so heavily favors products that we will assume 100% dissociation of HCl into H plus and Cl minus. Because we assume 100% dissociation, because we assume that the reaction goes to completion, we can say that this problem is a stoichiometry problem. So something that's helpful for you to keep in mind with these problems that we work with is if you have a question that involves a strong acid or it involves a strong base, that is a stoichiometry problem. And you can remember that by putting all of these S sounds together, right? Strong acid, strong base, stoichiometry, right? It all goes together like that. So let's talk about doing a stoichiometry problem. What we're going to begin by doing is writing the reaction that occurs. So HCl is dissociating into H plus and Cl minus. Now notice when I wrote this reaction, I wrote it with a one-way arrow. And the reason why I wrote it with a one-way arrow is because the reaction is going all the way to completion because this is a stoichiometry problem. So I'll make a note here. Because we can do stoichiometry, we can simply just use a mole ratio to convert the HCl into H plus. We don't have to bother with ice tables or anything like that because this reaction goes all the way to completion. You do complete conversion of all of the HCl into H plus. So what you can say is we have that it's a 0.8 molar solution of HCl, meaning 0.8 moles of HCl per liter of solution. And then we'll use the mole ratio, which is 1:1 in this equation. 1 mole of H plus is produced for every 1 mole of HCl that you have. Then we cancel out some units. So the moles of HCl cancel, and I've converted into moles of H plus. And I find that this solution contains 0.8 moles of H plus per liter of solution. And so what we can say is that the concentration of H plus in this solution is 0.8 molar. Having found the concentration of H plus, we can next determine the pH of this solution by taking the negative log. So the pH is the negative log of the H plus concentration. So that is the negative log of 0.8. When you plug that into your calculator, you find that the pH of this solution comes out to 0.097. And there we have it. That is how we would calculate the pH of a solution that contains a strong acid. You assume the reaction goes all the way to completion, making this a stoichiometry problem and allowing you to use the mole ratio to simply convert all of the reactant, all of the acid, into H plus ion. That brings us to the end of this video. In our next video, we'll talk about calculating the pH of a solution containing a weak acid.